So this is on 145 in the course workbook from Algebra Nation. And today we are talking about understanding zeros of polynomials. You know, last class I taught you how to understand the end behavior of a polynomial, which that's going to play a part in what we're doing today. But the main thing I'm teaching you today is what a zero is and how to find a zero when you're looking at a graph, how to find a zero when you're looking at a function, all that kind of stuff. All right. And you will have an assignment on today's lesson. All right, due next class. So quicker we can get through this, the more time you'll have in class to work. Let me know if you have a question. All right, let's examine the zeros of a polynomial equation. So a polynomial equation is a polynomial. We know what a polynomial is. That was what we spent that first lesson on. That has been set equal to 0, such that f of x equals 0. For example, f of x equals x to the 4th minus 5x squared minus 36 equals 0. Okay. The zeros of f of x are the solutions to that polynomial equation. A zero or a solution, so zero and solution means the same thing. You'll also see it called roots. I don't know why it has so many names, but it does. So if I say find the zeros, find the solutions, find the roots, that all means the same thing. Is the value of x such that f of x equals 0? Right now, this might all sound crazy, but don't worry. By the end, you'll know what I'm talking about. The zeros of f of x are also the x-intercepts of the graph. Y'all know this already. Remember when I taught you how to graph quadratics? And remember when we solved a quadratic, either by factoring or the quadratic formula or completing the square, every time we solved a quadratic, we were finding x equals some number, and that number was where the graph crossed the x-axis, right? I told you then, that's called a zero, a root, a solution. So we're basically working with that today, but it's just not just quadratics. We're doing polynomials with higher degrees, okay? Consider the following polynomial function. G of x equals x plus 2 times x plus 2 times x plus 5, x minus 5. What are the zeros of the function? All right, remember when I taught you how to factor and solve? You factor, and then once you get your factors, you set each factor equal to 0 to find the solutions, correct? So this is already in factored form. We like when that happens because we don't have to factor it. That says factored, although my R does not look like an R. Factored form. So if your polynomial is already in factored form, sweet. All you have to do is take each factor. How many factors do I have here? 3 factors. Take each factor and set each factor equal to 0. So I'll set x plus 2 equal to 0. I've got another x plus 2. I'll set it equal to 0. And my third factor is x minus 5. I'll set it equal to 0. Then I just solve for x. So for x plus 2 equals 0, how will I get x by itself? Subtract 2 from both sides. So that gives me a solution of -2. That's one of my solutions. Notice the sign is opposite of what it was in the parentheses, right? So if my solution is -2, the factor that went along with it was x plus 2. Well, isn't the next one going to have the exact same solution? Yeah, same factor, same solution. And what's x going to equal to on the last one? 5, because if I add 5 to both sides, x equals 5. 5. So I have 3 solutions, but 2 of them are the same, okay? Usually if you have a solution that's the same, you don't have to list it multiple times. You usually just say it once. So the blank of a 0 is how many times that number is a 0 of a specific polynomial. It is the multiplicity, M-U-L-T, I-P-L-I-C-I-T-Y, I think I spelled it correctly, multiplicity. So basically what that means, the multiplicity is how many times does the solution occur, okay? So in the above example, function g, how many times did the solution -2 occur? Twice. So we would say -2 has a multiplicity of 2. How many times did the solution x equals 5 occur? Once. So we would say 5 has a multiplicity of 1. Okay, that's all multiplicity means. How many times did the solution, remember solution is the same thing as a 0. How many times did the 0 occur? So the next question says, what is the multiplicity for the 0, x equals -2 in function g? That's saying how many times did we get a solution of -2? We already said the answer is what? 2. So I'm going to say -2 has a multiplicity of 2. That had nothing to do with the solution being the number -2, okay? How many times did it occur? It did not ask, but just for the sake of comprehension, let's say 5 has a multiplicity of what? 1. Everybody understand what multiplicity means? Don't even make me think you're looking at your phone. Because if I do, come on. Next page. Let's practice. Consider the following polynomial function. Show that 1 and 2 are zeros of the function. Okay, on your assignment today, this is exactly like one of the problems that you have to do, okay? If you don't show me your work, I'm not giving you credit, okay? So it's saying that 1 is a 0. It wants me to show that that's true. It's saying that 2 is a 0. It wants me to show that that's true, all right? So in order to prove that, if I substitute 1 into this function wherever I see an x, and I simplify using order of operations, the final result should be 0. I'm saying when x is 1, y is 0. I'm saying when x is 2, y is 0. If it's some other number other than 0, that's not going to be an ordered pair on the x-axis. It's not going to be a solution, a root, a 0. So in order to do this, I have to substitute each number in the function f. So it's 2 separate problems. All right? So let's start with 1. So I'm going to find f of 1. So I'm taking this problem wherever I see an x, and I'm going to be real careful with parentheses. I'm going to plug in a 1, substitute in a 1. So that would be 1 cubed minus 4 times 1 squared plus 5 times 1 minus 2. All right, order of operations. I still have students take care of the parentheses first. Okay, parentheses do come first in order of operations. That's the P, the PEMDAS, the please excuse me, Aunt Sally, that's the first thing, right? But parentheses mean there's something inside the parentheses that I can simplify. So my first set of parentheses, can I simplify 1 any further? No. How about my next set of parentheses? Can I simplify 1 any further? No. How about the last parentheses? No. If I do 4 times 1, I'm doing multiplication first. That's not what parentheses means. Parentheses means there's something inside parentheses that can be simplified. If there can be, great, simplify it. If not, move on to the E in PEMDAS, which stands for what? Exponents. Do I have exponents? Let's do it. So what's 1 cubed? That means 1 times 1 times 1. 1. Do I do -4 times 1 first or 1 squared first? 1 squared. So I'm going to bring down the -4 and I'll multiply it by whatever 1 squared is. What is 1 squared? Sweet. Now I know I can take care of some stuff. I can simplify along the way, but I'm just showing all my steps. So all I did in that step was exponents. So now I see I have addition, subtraction, multiplication. In PEMDAS, what do I do first? Addition, subtraction, multiplication? Multiplication. So this 1, I'm going to bring it down. What's -4 times 1? What's the sign? -4. +5 times 1? +5, and then bring down that -2. And then when we have addition and subtraction, we just work left to right. What's 1 minus 4? What's the sign? -3. What's -3 plus 5? And what's 2 minus 2? 0. So this is saying for this graph, when x is 1, y is 0. That's an ordered pair, 1, 0. So is 1 a 0, a root, a solution? Yes. We knew it was going to be because it says show that it is a 0. So if I got something else, something's not right. You know what I'm saying? So now I'm going to do the same thing, except for now I'm going to show that 2 is a 0. So I'm going to take the same function, but this time wherever I see an x, I'm going to substitute in a 2. So I'm finding f of 2. That just tells me my input's 2. So that will be 2 cubed minus 4 times 2 squared plus 5 times 2 minus 2. Is there anything inside any of those parentheses to simplify? There's a 2 in each of the parentheses. Can I simplify 2 any more than that? No. Okay. So the next thing I would take care of is what? Exponents. So I'm going to scoot this over, give me a little bit more room. So 2 cubed is what? Is it 6? It's 8 because it means 2 times 2 times 2, which is 8. Do I do -4 times 2 first or 2 squared first? 2 squared. Exponents come before multiplication. So 2 squared is 4. Everything else I'm just going to bring down for now. I was just taking care of the exponents. So now I've got addition, subtraction, multiplication. According to order of operations, what would I take care of first? Multiplication. So the 8 I'll bring down. Then I can do -4 times +4, which is what? -16, good. And I can do +5 times 2, which is +10, and then bring down your -2. Now, once you have just addition and subtraction, you should work left from right. So what's 8 minus 16? -8. -8 plus 10? +2 minus 2? 0. So did we show that 2 is a 0? Yes. When x is 2, y is 0. 2, 0. That's going to be an ordered pair on the x-axis. That means, yeah, it's a 0. Everybody cool with that? Do you have questions? All right, let's look at part B. Show that 0 is not a 0 of the function. I know that gets confusing. You're like, 0 is not a 0. What? Remember, show that 0 is not a solution of the function, not a root of the function. Too many words, 0 gets confusing. So when I plug in a 0, is my result going to be 0? No, because it's telling me it's not a 0, right? So we're going to prove it. I'm going to do the same thing I did above, except for this time I'm substituting in 0. So f of 0 equals 0 cubed minus 4 times 0 squared plus 5 times 0 minus 2. And of course, I've made notes of everyone who has their head down. Do not ask me for help when you're not helping yourself. And expect a lunch detention. All right, so we know we can't simplify inside the parentheses, so exponents come first. So what is 0 cubed? 0 minus 4 times what? 0 squared? 0. And then I don't have any other exponents. I know I can simplify along the way. I'm just doing my exponents right now. All right, now I'll take care of the multiplication. So I have 0. What's -4 times 0? 0. And does it matter if 0 if I put plus 0 minus 0? No, because 0 is really not positive or negative. And what's 5 times 0? And then bring down your -2. So what is 0 plus 0 plus 0 minus 2? Did we know we were going to get a number other than 0? Yeah. So did we prove that 0 is not a 0 of the function? Yeah, we did. It's not. Did not equal 0. The next one, I believe you have to do this on your homework as well. Write a polynomial equation that has a 0 of multiplicity 3. So they're just wanting us to write, I mean, we could all have a different answer, okay? As long as my answer, I have at least one of my zeros that occurs how many times? 3 times, because it says it has a multiplicity of 3. So I'm just going to do it in factored form. So somebody give me a x equals some number. What number you want to use? 7. So if x equals 7, what would that have looked like in parentheses? What would it be? What would it be as a factor? As a factor, x minus 7. Very good. Because when I set that equal to 0, wouldn't it be x equals 7? So if the solution 7, the factor was x minus 7. So if that's got to occur with a multiplicity of 3, wouldn't I need to write that 3 times? Right? Could I throw in something else? Could I throw in an x plus 2? Sure. And I could throw in whatever. But as long as I had 3 factors that were identical, then I'm going to have a 0 that has a multiplicity of 3. Does that make sense? Because this will be x equals 7. This will be x equals 7. This will be x equals 7. And what will x plus 2 be? Negative 2. Just totally made those numbers up. Does 7 have a multiplicity of 3? Did it occur 3 times? Yeah. That makes sense? Where did you get the number 7? Where did you get the number 2? We just made it up. It didn't say I had to use any numbers in particular. It just said I had to have a 0 with a multiplicity of 3. So I had to have a solution that occurred 3 times. Could I have also written that as f of x equals x minus 7 quantity cubed times x plus 2? Could have I written it like that? I could. We know that. Everybody cool with that? All right, let's look at the right side. Go try it. Find the zeros of the following polynomial function. Okay, the way this is written looks weird. Just let me explain it. They're saying function b is x cubed minus 9x. That's just the standard form of the function, okay? And then they said that's equal to x times the quantity of x minus 3 times the quantity of x plus 3. Then they gave us the factor form. So they just took the standard form and factored it for us. We like when they factor it for us. That means we don't have to do it, right? And factored form is so much easier to deal with when you're graphing a polynomial. So there might be a time when we have to factor them, but right now we don't. So what are the zeros of the function? Look at your factored form. How many factors do we have? What? 3. Because x is a factor. It was the GCF, right? Greatest common factor. So that's a factor. So x is a factor, x minus 3 is a factor, x plus 3 is a factor. If we know the factors, how do we find the zeros? Set them equal to 0. So x was a factor, set it equal to 0. Do I have to solve anything? No, that's one of my zeros, or my solutions, or my roots. X minus 3 is a factor. Let's set it equal to 0. And that's going to give me a 0 of what? Positive 3, because I add 3 to both sides. And my other factor is x plus 3. And that will give me a 0 or a solution or a root of what? Negative 3. Those are my zeros. If your GCF was a number, so like say in front of that first parentheses was the number 3, okay? If you set 3 equal to 0, does 3 equal 0? No. So 3 would be a factor, but it won't give you a root. But if that number or term is a variable, that's going to give you a root, all right? What is the degree of function b? No. How many degrees? What? 3. Remember, look at standard form. Your highest degree when in standard form is the degree of the function. So function B has 3 degrees. Is your leading term positive or negative? Positive. My leading term was x cubed, right? That's a positive number. If you weren't here last class, that's what you missed from the video, okay? Part D is wanting us to sketch the graph. Why do you think they asked us how many degrees there were and if it was positive or negative? So that we can determine the, what did we do all last class? And behavior. So if you have a positive, this is odd, right? A positive odd, first of all, is my end behavior going to be same direction or opposite directions? Opposite. So it's positive, it's going to be up, down, or down, up? Down, up. So we know the left side's going to point down, the right side's going to point up. This is going to, knowing, having that knowledge is going to help us sketch the graph. It's just a sketch. So it's not all going to be perfect, but we know a few things for sure, and we need to make sure we get those things right, okay? So first thing let's do, let's plot these zeros. So remember, these numbers tell us where the graph's going to cross the x-axis. So I'm going to plot those points. So I know it's going to cross the x-axis when x is 0. So I'm going to plot a point there. I know my graph's going to cross the x-axis at 3 because one of my zeros was positive 3. And I know my graph's going to cross the x-axis at negative 3. Those are the only 3 times it's going to cross. Here, now, if you leave your graph like that, that's not really a graph. That's 3 points on a plane. Am I right? Okay, here's where knowing the rules for end behavior help you. You know it's going to be a down and up, right? Far left side's going to point down, far right side's going to point up. You only have 2 arrows. So go, but we have 3 zeros. So go to the 0 to your far left, and we're just going to make an arrow coming off of it that's going to point down. You don't want to draw it straight down. We don't really know how steep it's going to be or how wide it's going to be. This is a sketch, but we know it's going to point down. The right side's going to point up. So go to your 0 to the far right, and let's make an arrow pointing up. Again, don't make it straight up. I don't know how narrow it's going to be, how steep it's going to be, or how not steep it's going to be. It's a sketch, but we know it's going to point up. All right. Here's the point. Here's the part that confuses kids. Well, how do we know what to draw in the middle? Well, you know, if we read a graph from left to right, it's not going to come up and then go straight across to this point, straight across to this point, right? We know it only crosses the x-axis at these 3 points. So the middle part is a total sketch. Unless you do some more math, I don't know if between this point and this point it goes way up high or it barely goes up. I don't know. It's a sketch. So I'm just going to come up and then I'm going to come back down at this point. Again, between 0 and 3, it could drop way down low or it could barely go. I don't know. It's a sketch. I'm just taking what I know for sure and then just sketching in the middle part. All right. If I wanted to know for sure, pick an x value between 0 and negative 3, say negative 2. Plug negative 2 into the function above, simplify, find a y value. That would give you a point to plot. If I wanted a point between these two, pick a number between 0 and 3, so positive 2, 1.5, whatever you want, plug it into the function, simplify, find your y value, that's an ordered pair. You can do that. But since it just said sketch, this is good enough. Does that make sense? Okay. The video from Algebra Nation, I posted the one that Amy does, and she does this whole lesson in like 13 minutes or something. So I'm doing it, I'm trying to go way more in depth and explain more. So that you have a good understanding. So you might need to rewatch my video. You might want to go back and rewatch Amy's. And then of course, if you go to Algebra Nation, there's 3 different people that record the same lesson. So if you don't like me or Amy, go to Algebra Nation, you'll find 2 more people who you can watch. Okay, let's practice page 147. We can also find the zeros of a polynomial function by looking at the graph of a polynomial. All right, so this one they graph for us. We're going to answer some questions. Part A says circle the zeros of f of x on the graph. All right, we got this. Somebody give me one of the zeros. -3. And be careful because it kind of looks like -4, but if you look at the graph, the -4 is the next line over, so that's a -3. What else? -1 and +1. So we did that. For what values of x does f of x equal 0? Okay, we already said it. It's what we circled. X equals -3, x equals -2, and x equals, what was that, +1? Oh, that's it. I'm sorry. So x equals -3, correct? And then x equals -1, and then +1. That's why old people like me should wear readers when you look at little tiny graphs. But I don't know what I do. All right, I'm going to point out something super important here. Soup's important, so you might want to wait. You might want to wait. Soup's important, okay? If you have a 0 solution root, okay, and the graph crosses over the x-axis at that 0, that means that number has a multiplicity of an odd number. So it can either occur once, 3 times, 5 times, 7 times, 9 times, whatever. They didn't give me what this polynomial is, so I don't know how many times it occurs. But I know that this x equals -3, that cannot have a multiplicity of 2. It can't. If it crosses all the way over, it has to have a multiplicity of an odd number. So it may occur once, 3 times, 5 times, etc. Okay? Same thing when x is -1. The graph crosses the x-axis. So x equals -1 can occur once, 3 times, 5 times, 7 times, etc. It has to occur has a multiplicity of an odd number. Same with 1. So you're like, okay, well, is that true for everything? Well, if you have a graph where your graph approaches the x-axis, it touches it, and then this is called bouncing. It bounces off like that. That means, so this has a 0 of 7, okay? If your graph bounces at the root, the 0, the solution, that means that that solution has a multiplicity of an even number. So if this was part of my graph, 7 would occur either twice, 4 times, 6 times, 8 times, whatever. It has an even multiplicity if it bounces. It has an odd multiplicity if it actually crosses the x-axis. Does that make sense? We don't need to know that here, but you're going to need to know it later and in your homework. Okay? Even if it bounces, odd if it crosses. Multiplicity. Let's look at the triad. Polynomial functions are often used to model real-world situations. The graph below models the rodent population. What is a rodent? Is a rat the only kind of rodent you can have? Huh? A what? Rats for sure. Mice, yeah. Beaver probably. I think of rodents as the kind of animal that you do not want to get into your attic, right? Are not rodents. Children are not rodents. All right. No. Pretty sure. Children are not rodents. Someone said children. Children are not rodents. Well, you don't want children in your attic, true, but they're not rodents. All right. The graph below models the rodent population, R of T, of a protected federal forest where T is the time and months since observations of the area began. What is the 0 of the function? (8.42). What does the 0 mean in this context? Months when what? How many rodents did they observe when they started this observation? About 1,000. How many, what was the maximum number of rodents they ever saw approximately? About 1,300. And how many months was that in? About 5 months in, right? When they started, there was about 1,000. About 5 months in, there was about 1,300 approximately. So what does this mean? In about a little, almost 8.5 months, what does that mean? They did not observe any, right? In approximately 8.42 months, there were 0 rodents observed. For whatever reason. Do we know the reason? No. Maybe they set up traps. Maybe, I don't know, do rodents hibernate? I don't know. But for whatever reason, in almost 8.5 months, there were no more rodents. Observed anyway. Everybody cool with that? Okie dokie. Last page. Beat the test. Now listen, Linda. If you have a problem like this on your homework and you just check 2 boxes because you text your friend and say, what boxes do I check? Or let me see your work, and you check 2 boxes, I'm not giving you credit on that. You got to show me, not just check 2 boxes, all right? So for which of the following polynomial equations is -1 a 0? Select all that apply. Do we just guess and check? Am I going to give you credit if you just put check marks and they're correct? No, you got to prove it. How? And it says select all that apply, right? So does that mean there can be more than one? Okay. How am I going to prove it? Plug -1 in, and how do I know? The result will be what? 0. And if the result's 0, then I'll check the box because it'll mean it's a 0, okay? I'm going to go through this kind of fast because I want to make sure I get to explain the last example and give you your assignment. Even if we don't have any time in class to do our work, is it still due next class? Yes. Do I have to give you time in class to do your work? No, I do when I can, but if I can't, it's still due next class. All right, so I'm going to start with function f, and like I said, I'm going to go fast. And I'm going to go ahead and plug in a -1 wherever I see an x. So I'm going to find f of -1. So that's, now listen, the negative and the 1 is being cubed. Be careful about that. -4 times -1 quantity squared minus 5 times -1. There's no simplifying inside the parentheses, so I'll go on to exponents. What is -1 quantity cubed? -1, because -1 times -1 times -1 is -1, right? Negative times a negative is a positive, positive times a negative is a negative. -4 times, what's -1 quantity squared? +1, because a -1 times a -1 is a +1. Now I'll do multiplication. So bring down your -1. What's -4 times +1? -4. What's -5 times -1? +5. All right, left to right. -1 minus 4 is -5. -5 plus 0 is, will we check that box? Yes, we will. If we're not checking the box either, it's because we didn't get 0, but be careful, is your math correct? You want to make sure your math's correct. So now let me do function g. So I'm going to find g of -1. So that's 3 times -1 quantity cubed plus 5 times -1 quantity squared minus 47 times -1 minus 15. There's nothing inside parentheses to simplify, so I'm going to go on to exponents. So 3 times, what's -1 quantity cubed? What? -1. Whenever you raise a negative to an odd power, it's always negative. Plus 5 times, what's -1 squared? +1. Now I'll take care of my multiplication. 3 times negative 1 is negative 3. Positive 5 times positive 1 is positive 5. Negative 47 times negative 1, positive 47. Bring down your negative 15. Pretty sure that's not going to give a 0. Negative 3 plus 5 is 2. 2 plus 47 is 49. 49 minus 15 is 34. Are we going to check function G? No. Anybody have a question about that? All right, let's do function H. So I'm going to find H of negative 1. So that's 3 times negative 1 quantity cubed plus 4 times negative 1 quantity squared minus 45 times negative 1 plus 50. So parentheses, there's nothing to simplify inside the parentheses, so I'll move on to exponents. So I have 3 times, what's negative 1 quantity cubed? Negative 1 plus 4 times, what's negative 1 quantity squared? Positive 1. Everything else, I know I can simplify some things, but I'm just going to bring it down. I was only doing exponents. Now I'll do multiplication. 3 times negative 1 is negative 3. Positive 4 times positive 1 is positive 4. Negative 45 times negative 1, positive 45. Bring down that positive 50. Is that going to give me 0? No. I got negative 3 plus 4 is 1. 1 plus 45 is 46. Plus 50 is what? 96? So negative 1 is not a 0 for function H. So G was not, H was not. Let's try M. So that's 3 times negative 1 quantity cubed minus 5 times negative 1 quantity squared minus 3 times negative 1 plus 5. Again, nothing to simplify inside the parentheses, so I'll do exponents. Do not do 3 times negative 1 first. Multiplication does not come before exponents. So what is negative 1 quantity cubed? Negative 1. Negative 1 quantity squared is positive 1. Multiplication. 3 times negative 1 is negative 3. Negative 5 times 1 is negative 5. Negative 3 times negative 1 is positive 3. Bring down the plus 5. So negative 3 minus 5 is negative 8. Plus 3 is negative 5. Plus 5 is 0. Is negative 1 a 0 function M? Yeah. Finally, another box to check off. So do I just guess and say, well, the last one's probably not, or the last one probably is? No, you don't. You don't. You do the math. We're not lazy. All right, function P. Woo. All right, negative 1 to the 4th. Is that going to be positive or negative? Positive. So that's going to be 1. Negative 1 times negative 1 times negative 1 times negative 1, positive 1. Plus 2 times negative 1 quantity cubed. Positive 1 or negative 1? Negative 1. Minus 13 times negative 1 quantity squared. Positive 1. No more exponents, so I'm just going to bring it down. Now let's do multiplication. So I have 1, 2 times negative 1 is negative 2. Negative 13 times 1 is negative 13. Negative 14 times negative 1 is positive 14. And then I have a plus 24. Does this look like it's going to give me a 0? Let's see. 1 minus 2 is negative 1. Negative 1 minus 13 is negative 14. Negative 14 plus 14 is 0. 0 plus 24 is 24. 0 plus 24 is 24. So is negative 1 a 0 a function P? No. So we do not check that box. Julio? Anyone have a question? All right, I'm gonna have to move on to the next page if you missed something. It's gonna be a video, Example 2. All right, this is a great example, okay? Especially if y'all are taking those college entrance exams or ACT or SAT. It's a great question for something like that. Consider the graph of the following polynomial function. All right, which of the following equation models the above polynomial function? Okay, well, first of all, what is the end behavior? What's the end behavior? The left side points and the right side points down and down. Okay, so is this going to be an odd or even? Odd, what? Negative even, you said the right thing. We know it's going to be a negative even, right? If you don't know that, it's because you weren't here last class, or you slept last class, or you didn't pay attention last class. So we know that. All right, let's look at the zeros. I'm going to have a 0 at -1. What's that going to look like inside the parentheses? +1. And how many times can +1 occur in this example? No, once or 3 times or 5 times. It's got to occur an odd number of times, right? Either once, 3 times, 5 times, etc. All right. How many times can 0 occur? Once or no, 3 times or 5 times or 7? Odd number. How many times can 2 occur? 2, 4, 6, 8. Okay, so we said x minus 1. What's that going to look like as a factor? X plus 1. So A has x plus 1 that occurs once. Is that okay? B has x minus 1 that occurs twice. Is that okay? No. C has an x minus 1 that occurs once. Is that okay? Isn't it supposed to be x plus 1? If the 0 is -1, in the parentheses, it's +1, correct? D has an x plus 1 that occurs once. Is that okay? Okay. Let's look at 0. So the x's in front of, that's going to be where you get your x equals 0 from. So that any of these would have it 1, 0. That's fine. 2, what's that going to look like in parentheses? -2, and we said it's got to occur 2 times, 4 times, 6 times, 8 times, etc. So look at F. How many times does x minus 2 would be x equals 2 occur in A? 2 times. What about D? Also 2 times. Okay. So what it boils down to is this first term. Now you're like, but wait a minute. These are both odd numbers, x to the first, x to the first. Well, remember, this is an in-standard form, okay? So let me show you how to figure out how many degrees your first term would have. This factor has an x value of 1, right? This factor has an exponent of 2. So you're going to have x squared. If I multiply that out, it would be x squared. And then this factor has an exponent. X has an exponent of 1. So if I multiplied everything out, your leading coefficient would be 1 plus 2 plus 1 would be x to the 4th. And I don't know what the number would be. I just know that it would have 4 degrees. All right, so that's even, correct? Down here, same thing. My first term has 1x. The middle term is being squared, so it's 2. The last term is just to the first power, so you have an x again. So if I multiplied all of this out and got it in standard form, it would have 4 degrees. So this is going to be an even, positive or negative? What's that first term? Positive. And this is going to be an even, negative. What do we need according to the end behavior? We said even negative, right? So that's the only difference in these two. Which one do we choose? D. See, if we did not know about the multiplicity, if it bounces or goes across, then that would be hard to figure out. If we didn't know the end behavior, we wouldn't be able to figure that out. But because we know all that stuff, we learned a lot, then we know how to answer that question. Right on? Crouton? Okay, so your assignment is technically in your practice book However, I do not have time. I wish I'd have just had y'all tear the whole practice book out, but I didn't. So I'm going to give you copies of the practice book page. And so I don't have to tear the practice book out, okay? So let me do that now. I'm trying to end my video. Let me just end the meeting. Now, once I give you this assignment, you are not to get on your phone until you're